Do you feel like using the castle law against your math homework because it's threatening you and your family's safety? Good. We can help you avoid defending yourself in court by checking out this here video by Fort Bend Tutoring and Mr. Witt.
Hello, ladies and gentlemen. This is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about divisibility. We'll be looking at divisibility with the first 15 natural numbers, aka counting numbers, and let's go ahead and point out why divisibility is so important for us. If you're having difficulty with any of these topics, it just might be, that if you were to master divisibility, you would really improve in these areas. These areas would include finding the prime factorization, simplifying fractions, oh yes, simplifying the fractions, factoring the GCF, finding rational zeros, long division, yeah, that one right there, long division, big time, finding the least common denominator, and finally factoring quadratic trinomials. And there are many other math concepts that are related to divisibility, and if you were to master it, that you would improve in those areas. So let's begin. Divisibility by the number 1. Yeah, the rule for that, ladies and gentlemen, is if it's a number, a real number, it's going to be divisible by it. And when I mean divisible by a number, that means that it will be a terminating decimal, meaning that if I were to divide that number by 1, it would go in there evenly, all right? It wouldn't continue with other decimals in the tenths place, in the hundredths place, in the thousandths place. No, it would terminate after I get to the ones place. Yeah, so that's what I mean by divisibility. It goes into the number evenly. It can be divided by that number. So let's look at some examples. If I look at problem A here, if I want to test the divisibility by 1 with the number 17, in other words, can 17 be divided by 1? Then the answer is yes. Why? Because it's a number. Yeah, it's a real number. Any number can be divided by 1. Let's look at B. B's fun. This is 1,385. It's a number. It's a number. It can be divided by 1. Yes, it can be divided by 1 because it's a number. Then if I look at C, you have negative 12. Now, negative 12 is a negative number. It's an integer, but yet still a real number. And yes, it can be divided by 1. And then you can just take this even further. Let's look at D. D is the symbol pi. Pi is a constant. It stands for approximately 3 1400ths. And yes, it can be divided by 1. Even a fraction can be divided by 1. Oh, yes, it can. I'm just expanding on this concept here. Even the decimal 3 6/10 can be placed over 1. In other words, it can be divided by 1 evenly. It would terminate with 0. I was just going to the extremes on the problem C through F, but I just wanted to make a point that if it's a real number, ladies and gentlemen, it can be divided by 1. Let's move on to the divisibility by the number 2. All right, let's check it out. Okay, here we go. Here's my, center it, center. There. Okay, great. Now, a lot of these rules that I give you are going to be redundant. They're going to be repetitive, but that's because I want to say it in different ways so that some of you will understand it one way and others will understand it better the other way. Okay, there you go. So, for starters, if I'm looking at divisibility by 2, that means that the last digit, that ones digit, is going to be even. It's going to be an even number. Or I could just say the entire number itself is an even number. Or I could say the last digit is either 0, 2, 4, 6, or 8. There you go. If you're looking at one of these situations here, it can be divided by 2 evenly. It's divisible by 2. The original number would be divisible by 2. It can be divided evenly by the number 2. So let's look at some examples. If I have 38, well, 38 has 3 in the tens digit and it has 8 in the ones digit. That last digit, looking at the number to the right, is 8. Yes, 38 is divisible by 2. Absolutely. I have a check mark right here. That's my check mark. Looking at B, 23, is that divisible by 2? Can 2 go into this number evenly? No, it cannot. Why? Because the ones digit, that last digit, the digit to the right, is not 0, 2, 4, 6, or 8. So no, it can't. Not happening. Looking at C, 64. Is that an even number? Yes, it is. So it's divisible by 2. So in other words, any number that's even can be divided evenly by 2. It's divisible by 2. So I'm going to put a check mark right there because I like check marks. So then we have D. This is going to be 560. Is 560 divisible by 2? Absolutely. You're doing awesome. I'm so proud of you. In E, we have 23,135. That's right. I said 23,135. Is this divisible by 2? Is it an even number? No. No, it is not. And I'm putting an X by it. Then I have F. This is 464,762. Is this divisible by 2, ladies and gentlemen? Is it? Well, is it? Yes, it is. There you go. Oh, I hate that check mark. Can you get a grasp of that? It looks like a boomerang. Not happening. Let's try it again. That's ugly. It's gonna have to do. It's gonna have to do. Obviously, those check marks are not gonna get any better for the F. All right, I got an F in the check mark area. Okay, so let's move on to the next problem. If I'm looking for divisibility by 3, well, the rule is simply this, that the sum of all the digits is divisible by 3. If I add all the digits of that original number together and it becomes a multiple of 3, then the original number itself can be divided by 3. And this rule can be recycled, meaning that once you get a result, you can start over again and find the sum of that number and see if it's divisible by 3. All right, so for instance, let's look at A here. With A, we have the number 78. Well, if I go ahead and add 7 plus 8, well, this gives me 15. Well, 15 is a multiple of 3. It can be divided by 3, and so therefore, the original number 78 can be divided by 3. It's divisible by 3. Oh, the recycle part. Okay, notice that we got 15, and let's say that you didn't realize that 15 was a multiple of 3, that 15 could be divided by 3 evenly. Well, you could take that 15, all right, and you could then add 1 plus 5, and you'll get 6. Since 6 can be divided evenly by 3, then yes, that means that 78 is divisible by 3. All right, so there you go. So notice that you may not recognize the value that you have in the first sum. You can take that sum itself and then continue. In other words, you can recycle the rule and end up adding the digits of that result, and you'll still get a multiple of 3 when you add them together. Yeah, check mark. All right, let's look at B. B, we're looking at the number 51. Is 51 divisible by 3? Will 3 go into 51 evenly? Now remember, yeah, you could use long division, but remember, divisibility is a method to instantly tell whether or not 51 can be divided by 3. Well, all I have to do here is just simply add the digits together. 5 plus 1 will give me, it gives me 6. So yes, this can be divided by 3 evenly because the sum of its digits, the original number 51, 5 plus 1 gives me 6, and 6 is a multiple, all right, of 3. It is. It's divisible by 3, so therefore the original number is. Now let's look at C. Let's see what happens here. We have 315. With 315, if you add 3 plus 1 plus 5, you'll get what number? Let's see, 3 plus 1 is 4, 4 plus 5 is 9. Is 9 divisible by 3? Yes, it is, because 3 times 3 is 9. So therefore, 315 can be divided by 3 evenly. It's divisible by 3. It's divisible by 3. There you go. What about D? All right, this problem here, this 422. Is this number divisible by 3? If I were to add the digits 4 plus 2 plus 2, let's go ahead and show that here. If I add 4 plus 2 plus 2, we'll end up with 8. Well, is 8 a multiple of 3? Can 8 be divided by 3 evenly? Absolutely not. It's not happening. It's not happening. Therefore, 422 is not divisible by 3. If I were to look at E here, the 17,813, if I add 1 plus 7 plus 8 plus 1 plus 3 together, we'll get what? Well, 1 plus 7 is 8, and 8 plus 8 is 16, and 16 plus 1 is 17, and 17 plus 3 is 20. Is 20 divisible by 3? No, it's not. And even if I were to try to continue this, by adding 2 plus 0, I would still get 2, which is not divisible by 3. So, no, it's not going to happen. Finally, let's look at this F right here, all right? If I have 560,166, is this number divisible by 3? That's the question. See, if you were to add 5 plus 6 plus 0 plus 1 plus 6 plus 6, what do you get? Well, 5 plus 6 is 11, 11 plus 0 is 11, 11 plus 1 is 12, and 12 plus 6 is 18, and 18 plus 6 is 24. Well, 24 is divisible by 3, isn't it? So the answer is yes. However, if you were to recycle that, in other words, do the rule all over again with the result of 24, you'd be adding together 2 plus 4, which is 6. And 6 is divisible by 3. So once again, you get a yes. Yes, absolutely. I think it's the last check mark. I figured it out. This last check mark on every page that I do from here on for the rest of my life is always going to be jacked up for no reason at all. All right? I'm going to fix it. No. See, I can't do it. It just won't work. I'm sticking with this. Let's continue. All right. Moving on. Divisibility by 4. So how can we tell if a number can be divided by 4 just by glancing at it, let's say? Well, the rule is the last 2 digits are divisible by 4, meaning that no matter how long the number is, if I just pay attention to the last 2 digits, if that is a multiple of 4, if those last 2 digits are divisible by 4, then the entire number has to be divisible by 4. All right, well, that means that you have to know the multiples of 4 until you get to 100. Because the last 2 digits, obviously, it's from 0 to 99. You'll need to know within that span all of the multiples of 4 in order to properly use this rule to your benefit. All right, so just keep that in mind. If I'm checking out A here, the number 86, is 86 a multiple of 4? Is 86 divisible by 4? All right, one and the same, right? Well, I do know that 4 goes into 80 evenly, all right, and let's just climb up from there. 80 plus 4 is 84, right? So if I add another 4, that'd be 88. It's not going to be 86. So no, it's not happening. It's not happening. 86 can't be divided by 4 evenly. Now, of course, once again, you can double check this by using long division, but the whole point is so that you can tell these things without having to use long division. Now let's look at B here. B has the number 144. Yeah. This is going to be a yes. All right. Notice how the check mark over here is better. Okay, you saw that? So if I just focus on the last 2 digits, it's 44 here. Well, definitely 44 is a multiple of 4. 4 goes into 44 evenly. Therefore, 4 will go into the original number, that's 144, evenly. Yes, 144 is divisible by 4. That's how we can tell. Just check out the last 2 digits, and if the last 2 digits are divisible by 4, then the entire number is divisible by 4. Let's see how that works with C. With C, we have the number 5022. Well, the last 2 digits of this number is 22. Is 22 divisible by 4? In other words, is 22 a multiple of 4? In other words, if I were to use long division, will 4 go into 22 evenly? Absolutely not. So therefore, that's not going to work. Okay, I'm moving on to D now. This is 33,516. The last 2 digits of this number is the 16. Is 16 a multiple of 4? What did you say? You said yes. Well, you're right. How right you are. You guys, you already understand this. Why are you here? Maybe it's for some of the numbers later on. We'll see. All right, so then, if I look at E, which is 137,702, is this number divisible by 4? Well, if I look at the last 2 digits, does 4 go into 2 evenly? No, it doesn't. It's too big, way too big. So no, it's not happening. But then if I look at F, the number 760, the last 2 digits of this number is 60, and 60 can be divided by 4 because 4 times 15 is 60. See, once again, I need to be comfortable with the multiples of 4 up to 99, up to 100, let's say, if this rule is going to be effective for me. So that means, all right, once again, just see, jacked up. The last one is always jacked up. So therefore, 760 is divisible by 4. Moving on. All right, divisibility by the number 5. That means that the last digit is going to be 0 or 5. You have a choice. If the last digit is 0, Or if the last number is 5, then the entire number is divisible by 5. So if we're starting out with A here, and we are starting out with A here, thank you. Let me go ahead and get that in view. We have 12,555. The last digit is 5. Therefore, the entire number is divisible by 5. You got it. You hate it? Okay. All right. Should I? Okay, all right, that's better. Should I just stop doing the check marks? Okay, so then we have B. We have 5,260. With the 5,260, my last digit is 0, so that means it is divisible by 5. Absolutely. Oh my God, with these check marks. Then for C. C is 177. Is the last digit of this number 0 or 5? Absolutely not. So therefore, this number is not divisible by 5. I know just by looking at the last digit that there's no way that this number here is going to be divisible by 5. It's not happening. The last digit has to be 0 or 5. It just has to be. Okay? Let's look at D. All right? With D, we have the number 23. Michael Jordan. Sorry. The last digit is 3. Okay? Is this divisible by 5? No, it is not. All right, the last digit has to be 0 or 5. It just has to be, okay? If I'm looking at E, 25,501, the last digit is 1. What do you say? Is it divisible by 5? Is this last digit 0 or 5? No. So therefore, no. It's not divisible by 5. If I look at F, and I am looking at F right now, you and I are looking at the same number together, simultaneously. Just saying. We have 83,510. Is this number divisible by 5? Yes, it is. And how do we know that? Because that's a decent check mark. Hold on, this is a decent check mark for me. Oh my God. If everyone could be just like that, I'd be so happy. So happy. All right, so yes, 83,510 is definitely divisible by 5. Let's look at the next number. All right, divisibility by 6. Now, if you were to break down 6 into its prime factorization, you will find that it's made up of 2 times 3. Therefore, the rule for 6 is that the number is divisible by 2 and 3. You'll take those previous rules we talked about, the divisibility rule for 2, the divisibility rule for 3, and combine them. In other words, I have it right here for you. The number has to be even and, very important, the sum of all digits is divisible by 3. All right, so when I add all the digits together, it has to be a result that's divisible by 3, and the number needs to be an even number, meaning that the last digit, that ones digit, ends in 0, 2, 4, 6, or 8. All right, so I know that this is an even number for A. The number 76, it's an even number. If I were to add the digits of 76, meaning adding 7 plus 6, I'll get 13. Now, is 13 a multiple of 3? No, it's not. Okay, it's not. So, no, that's not the answer. It's not divisible by 6. Then, if I look at B, is 87 an even number? No, it's not. The last digit is 7. See, I can stop right here. Now, if I were to add this 8 plus the 7, I would get 15, which is a multiple of 3, but both conditions have to be in play at the same time, meaning that it has to be an even number and the sum of the digits have to be a multiple of 3. So this is another no. It's not happening. But if I look at C, let's see what happens with C. Let's see what happens with C. Thank you. I thought of that just right now. If I add the digits 8, 7, and 0, okay, I'll get 15. And 15 is a multiple of 3. We know that. If we were to recycle that 15, if I were to add the 1 plus the 5, I would get 6, which is once again a multiple of 3. You see how that works now? You see how that works? And the last digit, oh, it's even. It's an even number. So yes, 870 can be divided evenly by 6. Looking at D, 111. If I add the digits 1 plus 1 plus 1, I do end up with a multiple of 3. In fact, I have 3 itself. I have the number 3 there. But is this an even number? No, it's not an even number. So no, it's not happening. No, it's not happening. Then looking at E, we have the number 888. Well, 888 is definitely an even number. The last number is an 8. That's good. But is the sum of the digits a multiple of 3? Let's see. If I add 8 plus 8 plus 8, I end up with 24. 24 is a multiple of 3, so that works. All right, 24 is divisible by 3. 3 goes into 24 evenly. Therefore, we have a winner for 888. And remember, you could recycle that. Once you got to that 24, you could add 2 plus 4 to get 6. And once again, 6 is divisible by 3, so therefore, there we go. Yeah, 888. It's divisible by 6. I know that now because I used the divisibility rules. All right, awesome. Now looking at F, we have the number 2013. Adding together 2 plus 0 plus 1 plus 3 gives you what? Say it again. Very good. It gives you 6. That's an awesome job of adding. Thank you. Is this also an even number, though? No, it's not. So therefore, this number is not divisible by 6. Once again, both conditions have to be met in order for the number to be divisible by 6. There you have it. Moving on. All right. To something that you may not know. The divisibility rule for 7. All right. Not that common, right? So let's see what it is. Subtracting the last digit multiplied by 2 from the other digits results in a number divisible by 7. Okay, that's one way to apply this method. Okay, let's see about another way to look at it. If you were to multiply the last digit by 2, then subtract it from the rest of the number, if the result, including 0, is divisible by 7, then the number is also divisible by 7. Now, basically, this is the same rule, just said a different way. I'm writing the rules in different ways because one of these may make sense to you better. All right, that's my hope at least. Okay, so let's go ahead and put this into practice. All right, being as though it's the same rule, it should be pretty easy, right? And by the way, this rule can be recycled again. Let's check that out. Here, my first example here is the number 161. All right. Now with this number here, this 161, this number, all right, if I check out the last digit and multiply by 2, I would get 2, right? 1 times 2 is 2. And if I take this 16, the rest of the number, okay, minus that 1 times 2, I'll end up with 14. And if this result is divisible by 7, then the original number is. So yeah, 14 can be divided by 7. I know that. So this is going to be, yes, 161 is divisible by 7. That's how it works. Let's try it again. Let's look at B. With B, we have 203. The last digit is 3. So what you do with that last digit, you multiply it by 2. So I'll end up with the first two digits, that 20, minus 3 times 2, which is 6. And I subtract that, and I get 14. Well, 14 is divisible by 7, which means 203 is divisible by 7. That's how that works. So once again, to show you, I'm saying 20 minus 3 times 2. All right, that's what I'm coming up with here. So I multiply that last digit times 2 and then subtract that from the rest of the number. All right, the rest of the number in that case was 20. Let's check out C then. With C, we have 1,421. Now, what you should be recognizing, especially if you're looking for divisibility by 7, is that the first two digits is 14 and the last two digits is 21. I'm thinking pretty much that 7 is going to be able to go in here evenly. All right, but let's just say we didn't know that. Okay, let's go ahead and start by multiplying the last digit by 2. All right, so that's 1 times 2 is 2, right? And then subtracting that from the remaining digits. So we'll have 142 minus 2. Once again, the 2 here came from me multiplying the 1 times 2. So I said 1 times 2 gives me 2, and I want to subtract that from the remaining digits, in this case, that 142 there. 142 minus 2 is 140. And I can tell that, yeah, 140 can be divided by 7, so the original number is divisible by 7. Now, what I meant by recycling is that if we were to take this last digit and multiply it by 2, that'd give us 0 still, right? And then 14 minus that 0 is still 14. So that's what I mean by you can recycle the rule. You can continue that process of taking the last digit, multiplying it by 2, and then seeing if the remaining digits gives you a result that's divisible by 7. Let's look at D here. With D, we have 707. Well, if I were to multiply the last digit by 2, 7 is that last digit, right? So 7 times 2 is 14, and then subtracting that, you end up with 56. Is 56 divisible by 7? Yes, it is. And how do I know that? Because 7 times 8 is 56. I know that. All right, so there you go. That works. And now for E, we have 3076. I don't know if this number is divisible by 7. I want to find out. So what do? I take that last digit, this 6 right here, and I double it. So I'll end up subtracting, you know that 6 times 2 is 12, right? It'll be 307 minus 12, all right? That 307 minus 12 is going to give you a result of 295. And now that I have 295, I really still don't know if this number is divisible by 7. So what I can do is I could recycle this process. I can do it over again. I can say if I take this last digit here, that's 5, and I double that, I'll end up with 29 minus 10. Well, that gives me a result of 19, and 19 is definitely not divisible by 7. So that means 3076 is not divisible by 7. All right, let's look at F. We have 581. So for 581, what we'll do is we'll double this last digit of 1. So that's 1 times 2 is 2. And we'll subtract that from 58. We'll say 58 minus 2. Well, 58 minus 2 is going to give us 56. And ladies and gentlemen, 56 is divisible by 7. So therefore, 581 is also divisible by 7. Absolutely. I hate this V. I don't know what that is. It's supposed to be a check mark. There you go. Much better. Much better check mark. So yes, so 581 is good. That one's good. And once again, that process for finding divisibility by 7 is to double the last digit and subtract it from the remaining digits here. So in that last problem, for example, we multiplied 1 times 2 to get 2. That's where this 2 comes from right here. And then we subtract this from the other digits in the number. All right, so there you have it. Done and done. All right, let's continue on. For divisibility by 8, I have an issue with the first version of this rule because it says the last 3 digits are divisible by 8. So if a number is divisible by 8, I would have to know all the multiples of 8 to 1,000. I'm not doing that. It's way too much work, and I'm too lazy for that. Okay, so that's one way to look at it. But we could expand on that with this other version here. And that is, if the hundredths digit is even and the last 2 digits are divisible by 8, then the original number, the entire number, is divisible by 8. Now, see, that's helpful to me because all I have to do is focus on the last 2 digits after I determine whether or not the hundredths digit is even. Okay, I can deal with this, all right? And then it has this coupled with it. It says if the hundredths digit is odd and the last 2 digits plus 4 is divisible by 8. All right, that I can deal with. All right, so those are decent rules. The first one, once again, is it's doable if you have all the multiples of 8 memorized up to 1,000, which I do not, and I'm not even trying. I'm not going to do that. I'm not going to do that. So yeah, I'm going to use these other 2, and that should get me through the divisibility rules that can assist me. All right, so here we go. All right. In example A here, we have 512. I know that the hundredths digit is 5. That tells me that I'm dealing with an odd numbered hundredths digit. Okay, and so what I need to do from there is take these last 2 digits here, that 12, and add 4 to it, and I end up with 16. If this value here is divisible by 8, then the original number is. And it is, because 16 can be divided evenly by 8. It's divisible by 8. So therefore, 512 is divisible by 8. This works out just fine. So the process is, I recognize that the hundredths digit is an odd number. So in that scenario, I take the last 2 digits, all right, the 12 that you're looking at here, and I add 4 to it. Once I get that sum, this sum must be divisible by 8 in order for the original number to be divisible by 8. That's the way it works, okay? So let's try it again, all right? We're looking at B now. We're looking at B, all right? Here's looking at you, kid. We have 1,720, all right? The hundredths digit is 7. That's an odd number. Therefore, if I take the last 2 digits, all right, that 20, and I add 4 to it, I should end up with a sum, a total that's divisible by 8. And it just so turns out that 24 is divisible by 8. So once again, I end up with a value this time, this 1,720, that happens to be divisible by 8. All right, so you guys catching on? All right, let's check it out. Let's look at C. This time, our hundredths digit is even. When the hundredths digit is even, you just simply look at the last 2 digits, in this case 24, and determine whether or not it's divisible by 8. Well, it is. We just said in the previous problem that 24 is divisible by 8. So this checks out. There it is. That's what's up. Once again, because the hundredths digit is even, all you have to do is just look at the last two digits to determine whether or not it's divisible by 8. And in this case, 24 is. It can be divided evenly by 8. Way to go. This is much easier for me to retain and implement versus trying to memorize all the multiples of 8 up to 1,000. It's not happening, all right? So this rule here, I can definitely do. All right, let's continue on to D. With D, we're looking at 17,962. I look at the hundredths digit, which is 9, and then I notice that it's an odd number, so I'm supposed to take that 62, add 4 to it, and then see whether or not that sum is going to be divisible by 8. And 66 is not. It's not divisible by 8. In other words, it's not a multiple of 8. In other words, 8 doesn't go into 66 evenly. It's just not going to happen. So, no, it's not going to happen. No. All right? So there you go. Looking at E now. With E, we have 1,233,456. Well, your hundredths digit is 4. And the last two digits are a multiple of 8. So that means, yes, this original number is divisible by 8. You see how easy that is now? I am so happy that I have this rule in my life now. Okay? I don't have to sit here and do long division to determine whether 1,233,456 is divisible by 8. Not bad. Not bad at all. Then looking at F here, we have 93,405,326. Since the hundredths digit is odd, I need to take the last two digits, that 26, and add 4 to it. I end up with 30. So is 30 a multiple of 8? Is 30 divisible by 8? No, it's not. It is not. So therefore, no. 93,405,326 is not divisible by 8. That was fine. All right, let's go ahead and check out our next rule for divisibility. The number 9. Here we go. The number 9. When you're checking for divisibility by 9, the sum of all digits is divisible by 9. That means you just simply add all the digits together, and if it's a multiple of 9, the original number is divisible by 9. Not bad. And this is one of those rules that you can keep doing over and over again. All right, so let's put that into practice. If we're looking at problem A here, we have 279. If I add these three digits together, all right, so you're adding 2 plus 7, which is 9, and then 9 plus 9 is 18, we should end up with a sum that's divisible by 9 if the original number is to be divisible by 9. And we do. 18 can be divided by 9 evenly. So that means that 279 can be divided by 9 evenly. Now, check this out. Remember we said we could recycle this rule. So if I take that 18 and add the 1 plus the 8, what do you get? Oh yes, you get 9. You see that? You get 9. So you can just keep going with it until you get to a familiar number where you know it's going to be divisible by that value. All right, so since 9 goes into itself evenly, obviously, you know what I'm saying? I got a check mark coming. I just put a check mark right there. All right, so let's move on to B now. For B, we have 540. If I were to add the digits of the number 540, 5 plus 4 plus 0, you would end up with 9. The sum is 9, adding the digits together. Is 9 divisible by 9? Oh, yes, it is. Check mark. I love it. This is too fun. Looking at C here, I have 962. If I add 9 plus 6, you get 15. 15 plus 2 is 17. Is 17 divisible by 9? No, it's not. It is not divisible by 9. So no, you're not divisible by 9. Then if I look at D here, we have 9,801. If I were to add the digits, we have 9 plus 8, which is 17. 17 plus 0 is 17. 17 plus 1 is 18. 18, son. Okay. And if you were to recycle that, the 1 plus the 8 still gives you 9, and lo and behold, that's a check mark. This check mark belongs over here. Okay, we're going to put you there. All right. All right, there you go. Okay, so now we have E. With E, we have 6,821. Okay, if I add the digits together, you'll have 6 plus 8, which is 14. 14 plus 2 is 16. 16 plus 1, though, is 17. So that's not going to work. That's just not going to work. Sorry. Okay. We're moving on to F now. Are you ready for F? Are you ready for F? Oh, you already did it? You already did it, so now you're showing off, right? So now you're showing off? Okay, let's see. We have 17,262. If I add the digits of this number, 1 plus 7 is 8. 8 plus 2 is 10. 10 plus 6 is 16. 16 plus 2 is 18. And oh yes, 18 is a multiple of 9. So that works out. Once again, here we go with the ugly check marks. Not having it. Okay, that's a little better. Just a little better. All right, now I want to share something with you. Okay, because I have a couple of degrees, all right, and the first of which is a bachelor's in mathematics. I had a bachelor's degree in mathematics and did not recognize this about the multiples of 9, and that is, let's say that this is a 0 right here, okay? Notice how the multiples of 9, check that out, all right? And the tens digit, you see how the tens digits works? The 10 digits goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it hits 9 again, but then it goes to 10. Check that out. All right? Okay. And then even further, you with your 11 and your 12. All right, so there's some type of sequence going on here. All right? But then, check this out. The ones digit. Okay, the ones digits 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Then it goes back to 9. 8, 7, 6, and on and on and on. Is that not cool? All right. Well, that's really not what I really wanted to show you. What I really wanted to show you is the fact that all my life up until this point, I didn't recognize that these numbers add to 9. It is crazy. 0 plus 9. Yeah, that's 9. 1 plus 8, 9. 2 plus 7 is 9. 3 plus 6 is 9. 4 plus 5 is 9. 5 plus 4 is 9. 6 plus 3 is 9. 7 plus 2, 9. 9. This one is actually 18 coming up. Just saying. But if you were to add those digits together, you'll still end up with 9. 108, those digits add to 9. 117, those digits add to 9. 126, those digits add to 9. I never recognized that all my life. Dealing with these numbers, didn't recognize that until like how old was I? Low 20s? I was like 22, 23 when I recognized that. Oh man. So anyway, I wanted to share that with you. So when you're dealing with numbers that are divisible by 9, the sum of their digits add to 9. All right, let's move on. We're now looking at divisibility by the number 10. Well, it's divisible by 10 if the last digit is 0. That's the divisibility rule. All right, let's check it out. Here I have A. A has the number 104. Is the last digit 0? No, it's not. With B, we have 220. Is the last digit 0? Yes, it is. So that means that 220 can be divided evenly by 10. 220 is divisible by 10. Nice. Now we're looking at C. C, we have 4,050. Is the last digit 0? Say it. Say it. Good. Yes, it is. So that means that, yes, it's divisible by 10. The original number, 4,050, is divisible by 10. Now I'm moving on to D. Thank you. With D, we have the number 11,718. Is this last digit 0? Is the last digit 0? No, it's not. So therefore, it's a no. Then with E, we have 203,560. Is the last digit 0? Oh, yes, it is. Yes, it is. And you get a check. You get a check mark. There you go. Then for F, what do you think about F, guys? What do you think? What do you think? Say it. Good. Okay, it's a no. It's a no. All right. Why is it no? You there. Yes. You there in your living room, looking at your iPhone, watching this video. Hey, why was this 0 again? Tell the class. Great. You're right. It's because the last digit is 5. It needs to be 0 in order to be divisible by 10. You're absolutely right. Very good, John. All right, so now we're moving on. Oh, his name was John. Yes, I knew his name was John. All right, just like I know your name is Pam. I'm sorry, Paul. I mean Stephen. I mean Michael. I mean Felicia. I mean Sarah. Anyway, you know your name. All right, so anyway, try to trick me. We're going to now move on to divisibility by 11. All right. Oh, that looks wordy. The divisibility rule for 11 is as follows. Subtracting the last digit from the other digits results in a number divisible by 11. Now, that's one way to approach this. Another rule that would work is to subtract the sum of the digits of the even numbered places from the sum of the digits in the odd numbered places, or vice versa. If the result, including 0, all right, is divisible by 11, the number is also divisible by 11. We need to check this out, okay? Let's see what happens here. For our first example, we have the number 143. If I subtract the last digit from the other digits, I end up with 11. Is 11 divisible by 11? Yes, it is. Boom. There we go. There we go. That's it. That checks out. That's it. Okay? Then let's check out B. B, we have 275. So if I subtract 5 from 27, I get 22. Is 22 divisible by 11? Yes, it is. So that means that 275 would be divisible by 11. So far, so good, right? Okay, great. Now, I'm looking at a number that has more than 3 digits in it. Okay, so this is going to stress me out. So I'm not going to use that first rule. I'm going to attempt to use the second rule. And the second rule says that if I subtract the sum of the even number digits from the sum of the odd number digits, and I end up with either 0 or a multiple of 11, then the original number can be divided by 11. So notice that I have a 7 and a 9 in the second and the fourth spot, right? Well, that's 16. And then for the odd numbers, I have 7 plus 9 for the first and the third spot, so that's also 16. So 16 minus 16 is 0. Well, 0, all right, is part of the rule, so this works out just fine. That number, 7,799, is divisible by 11. All right, cool. Let's see how this works over here with this problem. Problem D, where we have 49,753. So I'm going to highlight my odd numbers, all right, and I'm going to subtract the even numbers from that. So let's start out by adding 4 plus 7, which is 11, and then 11 plus 3 is 14, okay? Then if I were to combine the 9 and the 5 together, that's going to be 14 as well, right? And then 14 minus 14 is 0. And so if it's 0 or a multiple of 11, then that means that the original number can be divided by 11. All right, so I now know that 49,753 can be divided by 11, and with practice, this will definitely be faster than using long division to determine that. So there you go. Not bad, right? All right, let's try the next problem. For E, we're going to go ahead and highlight the odd numbered places, okay? So if I start with 1 plus 7, which is 8, all right, minus 1 plus 0, all right, that's just 1. 8 minus 1 is 7. Well, is 7 divisible by 11? No, it's not. So that means that 1,170 is not divisible by 11. All right. Now we're looking at F here. And for F, we have 484. So I'm going to go ahead and go back to the first rule that I was using, and I'm going to just simply subtract that last digit from the other 2 digits here. So notice if I have 3 digits, I use that first rule, and if it's bigger than 3 digits, I'll use the other rule. So I'll just subtract 48 minus 4, that gives me 44, and it turns out that 44 is a multiple of 11, so yes, 484 is divisible by 11. All right, that's how we do it. Good and good. Let's now move on to our next example here. The next divisibility rule is for the number 12. All right, so here we have it. And for this rule, the number has to be divisible by 3 and 4. That's one way to say it, okay? Or you can sum this up by saying the sum of all digits is divisible by 3 and the last 2 digits are divisible by 4. So that kind of like merges the rules for 3 and 4 when we're looking for divisibility by 12. So let's check it out in our first example here, problem A. We're looking at 888. If I look at the sum of all the digits, that's 8 plus 8 plus 8 gives me 24. Well, 24 is a multiple of 3, so that part of the rule is good. Then the last 2 digits need to be divisible by 4. Well, 88 can be divided by 4. Once again, for that divisibility rule for 4, you want to know your multiples of 4 at least to 100, okay? So that will maximize the use of that rule if you know your multiples of 4 up to 100. So since I know that 88 can be divided evenly by 4, then that means that overall, this number right here, that 888 can be divided by 12. It passes both rules, and that's why I know that 888 can be divided by 12. All right, so now let's look at B. For B, we have 1,023. The first step that I'm going to do is see if it's divisible by 3 by adding all the digits together. So I have 1 plus 0 plus 2 plus 3. That gives me 6. And 6 is a multiple of 3, so that works. Then it also has to be divisible by 4. And if I look at the last 2 digits, 23 is not a multiple of 4, so this number is not divisible by 12. Both conditions must be met in order for you to have divisibility by 12. And now for C, we have 4,908. Is this number divisible by 12? That's what we want to know. So what I can do is I can start by adding together the digits to see if it's divisible by 3. So for instance, if I add together 4 plus 9 plus 0 plus 8, 4 plus 9 is going to give me 13, and then 13 plus 0 is still 13, and then finally 13 plus 8 gives me 21. Well, 21 is divisible by 3. So it passes that first part of the rule. Now we want to see if the last two digits, this 8 right here, is divisible by 4. And it is. Yeah, we know that 8 can be divided by 4 evenly. So this number, 4,908, is divisible by 12. Once again, this is something that I would not be able to tell just by looking at it. But with the divisibility rules, I can verify that 4,908 is divisible by 12. All right, let's check out D here. We have 14,820. All right. First of all, we want to see if this number is divisible by 3. If we add together 1 plus 4, we get 5. 5 plus 8 is 13. 13 plus 2 is 15, and 15 plus 0 is 15. That sum is a number that's divisible by 3. All right, we know that 3 times 5 is 15, right? Then, is the last two digits divisible by 4? Let's see. Well, our last two digits is 20. And is 20 divisible by 4? Absolutely. It absolutely is. Great job, guys. So that means that, yes, this number 14,820 can be divided by 12. Absolutely. Now we're looking at E. With E, we have 12,116. Adding the digits together to see if it passes the first part of our rule, which is the number divisible by 3, we're going to find the sum of the digits. We have 1 plus 2, which is 3. 3 plus 1 is 4. 4 plus 1 is 5. And then 5 plus 6 is 11. 11 is not a number that's divisible by 3. It can't be divided evenly by 3. So therefore, this number can't be divisible by 12. All right. Finally, we're looking at F. With F, we have 11,628. With this number, checking for the first rule, we'll have 1 plus 1 is 2, 2 plus 6 is 8, 8 plus 2 is 10, and then 10 plus 8 gives us 18, and yes, 18 is divisible by 3. So therefore, it passes the first part of the test. Finally, we need to check to see if the last two digits is divisible by 4. And it just so turns out that 28 can be divided by 4. We know that 4 times 7 is 28, right? So yes, 11,628 can be divided by 12, and we know this by using the divisibility rules. Amen, amen. All right, let's turn the page. Now, divisibility by 13. Let's check this one out. The divisibility rule for 13 is multiply the last digit by 9, then subtract it from the rest of the number. If the result, including 0, is divisible by 13, the number is also divisible by 13. That's the rule for 13, ladies and gentlemen. Okay, let's go ahead and see what it looks like. Starting out with example A here, we have 442. The last digit is 2, right? So what I'm going to do is I'm going to take the remaining digits, which is 44, minus 2 times 9. Multiply the last digit by 9, and you'll end up with 18. Subtracting 18 from 44, we get 26. And you want to check to see if 26 is a multiple of 13. If 26, in other words, is divisible by 13. And it is, because 13 times 2 is 26, and I know that. So there you go. The original number, 442, is divisible by 13. All right. So once again, what was that process? You take the last digit, you multiply by 9, and then subtract that result from the remaining digits. In this case, my remaining digits were 44. All right, let's see if that works with our next problem. All right, 754 is the problem. It's the number that we're checking for divisibility by 13. I'm going to start out by recognizing that I'll have that 75 minus, you multiply the last digit times 9. So 4 times 9 is 36. 75 minus 36 is 39. All right, well, is 39 divisible by 13? It sure is, because 13 times 3 is 39. That works. All right. So what do you think about this rule so far? Pretty neat, huh? All right. I like it. Wish I would have known this a long time ago. Here we have 2,848. So, as the rule goes, we're going to go ahead and take this 284 and subtract 8 times 9 from this. So 8 times 9 just so happens to be 72. Subtracting 72 from 284, you're going to end up with 212. Well, I'm not that familiar with 212. Fortunately for us, we can recycle this rule. What we can do with this is you can subtract 21 minus 2 times 9, which is 18. But when you simplify this, 21 minus 18 is 3, and 3 is not a multiple of 13. Therefore, the original number is not divisible by 13. All right? So that's the way that works. Okay? So let's look at that again with an even larger problem. Problem D. We have 74,984. All right? So that means that we would subtract 4 times 9 is 36. So we would subtract 36 from 7,498. All right. This result that you'll end up with is going to be 7,462. So I'm not familiar with 7,462. So remember, we can recycle this process. We can keep doing it over and over as we whittle down the number. So multiplying 2 times 9, you get 18. So you'll have 746 minus 18. This value is going to give you 728. Well, it just so turns out that I'm not familiar with this number either. So multiplying 8 times 9 gives me 72. And then I'll end up with something interesting. 72 minus 72 is 0. And since 0 is divisible by 11, then that means that the original number is as well. So this one actually checks out. This 74,984 is divisible by 13. All right, so there you have it. That's what's up. We recycled it over and over again. We kept doing that rule over and over until we got a familiar number that we knew would be divisible by 13. And that's it. All right. So let's go ahead and look at this problem E here. Okay. With E, we have 3,626. So I'm going to multiply 6 times 9 to get 54. So you'll have 362 minus 54. This gives you a result of 308. I'm not familiar with 308, so I'll be multiplying 8 times 9, and they'll give me 72. So 30 minus 72 gives me a negative number. I don't recall our rule dealing with negative numbers. So therefore, this 3,626 is not going to be divisible by 13. Not happening. All right. For problem F, we have 2,356,461. Oh my God, why did I put this big long problem here? I'm going to go ahead and save us some time, ladies and gentlemen. This is not going to be divisible by 13, but bottom line, the process will remain the same, but you would have to whittle that down all the way. In a situation like this, that would take way too long. Just go ahead and use long division. If the number gets that big, that's just crazy. The process will take way too long. You'd be better off just using long division to see if that'll go in there evenly. Okay, so there you go. So I'm thinking that a safe bet is 5 digits. Anything beyond that, the process will become so cumbersome, you might as well have just tried to divide it outright using long division to see if it's divisible by 13. That's the divisibility rule for 13, and now we have 2 more. Let's turn the page. Okay, for the divisibility rule for 14, the rule is the number is divisible by 2 and 7. So that means that it needs to be an even number, and it has to pass the divisibility rule for 7. That's the one where we multiplied the last digit times 2 and then subtracted it from the remaining digits, okay, to see if that result would be divisible by 7. So let's look at our first example here, which is 560. So, yes, it's an even number. So that's a good start. And if I multiply 0 times 2, I get 0. So 56 minus 0 is 56. And 56 happens to be divisible by 7. It is. So 560 is divisible by 14. All right, there you have it. For B, we have 9,982. So it is an even number. So it passes that part of the divisibility rule. And then what we're supposed to do is multiply 2 times 2 and subtract it from the remaining digits. So this is going to be 998 minus 4, which gives us 994. Okay, so from there we may want to go ahead and recycle this. So that means that I would end up with 99 minus 4 times 2 is 8. All right, well, 99 minus 8 is going to be 91. And you know what? 7 goes into 91 evenly. Yeah, it does. So that means that 9,982 is divisible by 14. Absolutely. It passes both parts of the test. All right, let's check out C. With our C value, we have 3090. All right, so starting out, it is an even number. That's great. And then if we were to double that last digit and subtract it from the remaining digits, we would have 309 minus 0, which is 309. Okay. Well, I'm not familiar with whether or not 7 will go evenly into 309. So I'm going to go ahead and double the 9, and I'll have 30 minus 18, which is 12. And 12 is not divisible by 7. So that means that 3090 cannot be divided by 14. When I'm looking at D here, I'm like, oh my God, that's just way too much work. Way too much work to do the rule on. So I would just go ahead and use the regular long division. You would have to recycle this too many times to do it. Even though we could apply the rule to this number, the number is going to require too many iterations to solve it. So I'm going to go ahead and just let you know that, yeah, that can be divided by 14. It is an even number, so I would go ahead and try it, but I would definitely use long division here. I would not keep recycling that 4 or 5 times to get that answer. It would take too long. It would take you less time to go ahead and just divide it using long division. All right. Now, what I will do is E and F. Let's check that out. So with E, we have a situation where we end up with an odd number. Well, that already disqualifies this number. The number has to be even. This is not an even number. So this definitely will not be divisible by 14. With F, we'll take a look at subtracting 4 times 2, which is 8, and 22 minus 8 is 14, and 14 is a multiple of 7. So that means that the original number, 224, can be divided by 14. Done and done with 14, ladies and gentlemen. Let's move on to our last divisibility rule, and that is the divisibility for 15. The rule is the number is divisible by 3 and 5. So that means you're going to combine the two rules that we learned for divisibility of 3 and 5. Remember, for the divisibility of 3, the sum of the digits has to be a multiple of 3. And the divisibility rule for 5 is that the last digit has to be either 0 or 5. So here in A, we have the number 45. Well, I already know this answer is yes, because 15 times 3 is 45. But let's say I didn't know that. If I add together the digits 4 plus 5, I get 9, which is a multiple of 3. So that part works. And my last digit here is 5. All right, so that works. This number is divisible by 15. Then looking at B, we have 105. Adding the digits together, you have 1 plus 0 plus 5. That gives me 6. That is a multiple of 3, so that part is good. And my last digit is either 0 or 5, so that checks out. So that means that 105 is divisible by 15. Now, looking at C, we have 630. Adding the digits together, you have 6 plus 3 plus 0. That gives me 9, which is a multiple of 3, so that's good. And the last digit is 0 in this case. Well, that's okay. For divisibility of 5, it can be 0 or 5. So that means the original number, 630, is divisible by 15. Now I'll be looking at D. With D, we have 1,205. Adding these digits together, you have 1 plus 2, which is 3, and then 3 plus 0 is 3, and then 3 plus 5 is 8. 8 is not a multiple of 3, so this number is not divisible by 15. It's not going to happen. When I look at E, the first thing that stands out is that that last digit is not 0 or 5, right? So it's not going to be divisible by 15. Same thing happens when we're looking at F. The last digit must be either 0 or 5 for it to be divisible by 15. So that means that it's not going to happen. That 97,101 is not divisible by 15. Well, ladies and gentlemen, this concludes our lesson for today, and it's on divisibility 1 through 15, the first 15 numbers to determine whether or not quickly if they're divisible by those values. I hope this has been helpful to you. It was extremely helpful to me because some of these rules I didn't know. So I'm showing myself at the same time I'm showing you guys. So I appreciate you watching. As always, please rate, comment, and subscribe. And if you're able, please donate, as that helps us bring you more free math tutorials from me, Mr. Witt, and Fort Bend Tutoring. Peace.
Thanks for watching. We feel great knowing that you got some help and you're safe and sound. Now, if you'd be so kind as to like this video, subscribe to our YouTube channel, Fort Bend Tutoring, and like us on Facebook, we'd be much obliged.